Hello, everyone, and welcome. On this pleasant evening, it is my privilege to welcome all of you to this wonderful interaction. We at Space are constantly working towards the development of science and astronomy in India, aiming to create a scientifically aware society and contribute to the technological and social development of the country. Space is providing services and products in the area of astronomy and space sciences to schools, colleges, NGOs, corporations, markets, and individuals. Our trademark will always be innovation, passion, and total commitment to spread knowledge of astronomy and space sciences amongst the masses. Every project we conduct is an opportunity for us to communicate our belief in developing scientific temperament in people, especially children, to create an intelligent and analytic global community. And so here we are today, and I, Apuru Kishle, on behalf of the whole team of Space, with immense pleasure, want to welcome our guests, Professor Prajwal Shastri. Professor Shastri has been an astrophysicist for nearly 4 decades. She got her PhD from the Tata Institute of Fundamental Research, and after postdoctoral research positions in the University of Texas at Austin, University of California at Berkeley, and Harvard Smithsonian Center for Astrophysics. She was a faculty of the Indian Institute of Astrophysics for 23 years. In her research, she specializes in the investigation of giant black holes that are found in the center of distant galaxies. To study these objects, she uses telescopes at frequencies ranging from radio to X-rays. She's also deeply concerned about the inequities in the sciences, and she's extremely passionate about scientific outreach. She believes that the cultivation of scientific thinking is for everyone and uses astrophysics as a vehicle to engage audiences of all ages for these questions. I would also like to welcome our students and parents, as without their support, this interaction wouldn't be possible at all. The journey with the students so far has been very exciting, and our educators always put their best efforts to guide and help them in showcasing their hidden qualities. The young ones here with us are the ones that will shoulder the weight of the future. Now, as you know, today, on the occasion of National Science Day, we are here to discuss an integrated approach in science and technology for the sustainable future. The world is currently grappling with extremely complex issues like climate change, increasing instability of society, disruptive emerging technologies. The challenges that we are facing are both on the ecological and sociological fronts. The reverberations of these problems have the potential to ring throughout human history to the future of humanity. Solutions based on well thought out technologies and cutting edge scientific research may be the key to deal with these issues. So without further ado, let us begin unfolding the knowledge. We are very thankful that Professor Shastri is with us here today. So let's unfold the knowledge that is awaiting. And I want to call upon Professor Shastri to share her views about the issue with us. So over to you, Professor Shastri.
Okay, can you see my screen and hear me and all that? Can you see my screen? Okay.
Yeah.
And hear me?
Yeah, we can hear you loud and clear.
Okay. In the next 15 minutes, I hope to provide you with perhaps an astrophysicist's perspective on how to imagine a sustainable future and how to move towards such a future. So this is the kind of view you would have of the night sky if you were fortunate to be in one of these dark places. But most of us, unfortunately, are bogged by this, which is basically technology gone wrong, and where we send most of the light that we need here on the ground out into space. But there are some people like my friend who took that photograph who are lucky, and they post all these beautiful photographs on Facebook. So here you see the Milky Way, and there are all these little dots, shining dots, and most of them we know are stars in the Milky Way. The fascinating thing is that when stars finish their nuclear fuel and stop shining because they stop burning, they could, if they're heavy enough, collapse into what we call black holes, which are chunks of space-time from which even light cannot escape. But interestingly, in the center of our Milky Way, there is a huge black hole. Many of you probably know about this because it is a very famous discovery because it won the Nobel Prize in 2020. And here is the rendering of that result by the scientist Andrea Ghez, which is basically an animation of images of the very center of the Milky Way, taken in the infrared. So the multicolored splotches that you see are real data and represent stars observed in the infrared. And these were imaged continuously from 1995 onwards, and that's still continuing. And then all these images were put together to make an animation, and there are curves there which are meant to guide the eye to show you what these stars are doing. And so you can see that the stars are not moving in random orbits. They're moving very systematically. In fact, they're moving in elliptical orbits, very reminiscent of our planetary system. And in fact, all the elliptical orbits seem to have the same focus. So that white star-like thing that you see in the center, that's not real data. That is just to mark the position of something which must be gravitationally driving all these stars. And of course, using Keplerian orbits, one can calculate the mass that is driving these stars from the star orbits that makes closest approach to the center of this mass. We get an upper limit on the size, and both of those together tell us that it must be a very big black hole, namely more than 1 million times the mass of our sun. And we call such black holes giant black holes, and they're different from the black holes that are created during stellar death, because not just that the mass is much bigger, but also those created by stellar death are distributed all across both our Milky Way and other galaxies. But these giant ones are only in the centers of galaxies, and they clearly have a very different formation process. So I won't get into that, but it turns out that our Milky Way is not special at all. Just like our sun is not a special star at all. And all of these nearby galaxies, which can be observed with sharp enough imaging with our telescopes, show evidence for such giant black holes in their centers. And all of these black holes can't be seen directly because they're black holes, but if some matter, whether stars or gas, happens to come near the black hole, it's of course drawn towards it. And due to the black hole being a black hole, this matter will be drawn and start swirling around the black hole before eventually plunging into it, because there is very little matter in the universe which sort of goes along a straight path. Most of the matter has some angular momentum associated with it. So the matter will swirl around and then plunge in. But in the process get heated to extremely high temperatures and therefore create plasma and magnetic fields. And some of these, these magnetic fields can get twisted up and drive some of that plasma outwards. And it could go outwards into the galaxy, which is what happens in virtually all cases where matter approaches very close to a black hole. But in the minority of cases, there is so much power in this plasma that they are squirted out into intergalactic space. So this is an example of that, where you have a visible light image, and this is the galaxy with what you see here are all the stars. These are all things in the foreground, either galaxies or stars. And you see this evidence of this plasma being squirted out in both directions out into intergalactic space, which becomes visible most easily if you take radio images. And the best explanation we have can be illustrated by sort of an adaptation of the black hole Gargantua, the fictitious black hole that appeared in Interstellar, And so that's what I've shown here. And these are not unusual either. So we know many, many examples of galaxies with giant black holes that have matter swirling around them, which create plasma, magnetic fields, and then these very, very high power jets of plasma that go out into intergalactic space. And one of them, known as Messier 87, which is over here, that has been studied with a lot of depth. And it has, what you see here is the vestiges of previous squirting out of jets that have moved very, very far away into intergalactic space. But it also has a jet currently active in this area, and that is what I'm showing you here. And this jet, oops, sorry, this jet is imaged in the radio, at radio frequencies, visible light frequencies, and X-ray frequencies. And this particular galaxy was imaged with the best, the sharpest imaging capability that we have. And what that revealed, it was the business of getting into the business of zooming in a million times. And what that revealed was the silhouette of a black hole, which indeed was predicted by the kinds of simulations that were rendered in Interstellar in the form of Gargantua. So, so we know that these black holes exist and they do all kinds of things. Now, here's an example from my own work where there's this galaxy called the Karaf galaxy, which is gravitationally interacting with two others, but it turns out it itself is what we call a merger remnant. So two galaxies have come together in it and are now kind of coalescing into one big galaxy, and it still retains two separate giant black holes from the two parent galaxies, which we can image in the visible light, in radio light, and in X-ray light. So this is a picture of a very, very nondescript piece of sky, the size of about a tenth of that of the moon. And when the Hubble Space Telescope took a very, very long exposure, it showed about 10,000 galaxies in that small nondescript piece of sky. And of course, because it was a nondescript piece of sky, randomly chosen, not randomly chosen, but it could have been anywhere in the sky. So this has to be the story repeated all over the sky. So just think of these billions and billions of galaxies. And so each of these, there are about 10,000 galaxies in just the small piece of sky. Each of these galaxies has roughly 100 billion stars, each of them possibly with a planetary system. So where is the Earth in all of this? We know this, Carl Sagan told us long ago. It is just this really lonely pale blue dot that looks so fragile in this image that was broadcast many, many years ago. It was an image deliberately taken at the suggestion of Carl Sagan by one of the spacecraft that was launched at the time. And so, if I look back to that era, if I think about how I got into all this, I was born the year after Sputnik was launched. Yuri Gagarin and Valentina Tereshkova were my childhood heroes. I, at age 8, came across the gold foil experiment by Rutherford and was completely floored by it. I read these books, Curie's biography and this book on Prelude to Mathematics, which is touted as one of the best math textbooks ever. And also, of course, science fiction. And this was one of my favorites, called Andromeda, and it's about space travel and a space age tale and all of this. And so I dreamt about being a scientist on a spacecraft and all that. I just wanted to point out that these mathematics books are absolutely fantastic. And there is an organization in Pune which actually has a collection, which is a memorial to W.W. Sawyer, who was one of the fantastic mathematics teachers. So this was, shall we say, the first image taken of the Earth from outside, which was broadcast then all over the world. And I wanted to read the quotation by Dan Rather, because Carl Sagan's quotation everybody knows. So I wanted to read Dan Rather's quotation where he says, "This image, so peaceful and yet so breathtaking, was taken at the end of a turbulent year. It was Christmas Eve, 1968, but from up there you would never know that a hot war was raging in Vietnam or that a cold war was dividing Europe. You wouldn't know of the assassinations of Dr. Martin Luther King or Bobby Kennedy. From that distance, people are invisible, and so are cities, countries, national boundaries. All that separates us, ethnically, culturally, politically, and spiritually, is absent in this image. What we see is one fragile planet making its way across the vastness of space." So, what has subsequent decades told us? This told us that there is no planet B. Right? There's only this one thing, and that is what needs to be preserved. Gandhiji said, "The earth is sufficient for everyone's need, but not everyone's greed." And so there is this group of astrophysicists calling themselves Astro for Planet Earth, and they have written an open letter which goes, "We astronomers, astrophysicists, and global citizens recognize the urgency of the climate crisis and our impact on it. We also recognize that we have the power to change our current practices. We call on astronomical institutions worldwide to set an example for the field in mitigating our contribution to climate change, naming sustainability as a primary goal, putting in place specific sustainable practices to lower carbon emissions, and clearly communicating these changes both to their own members and general public. Comprehensive scientific evidence clearly demonstrates that we are living in a climate emergency that calls for urgent action." So the point is that I think I have to disagree with something that, sorry, your name is Apur?
Apur.
Yeah, said that the key lies in technology. I don't think the key lies in technology. Technology is necessary, but certainly not sufficient. So I wanted to stop with a quotation from Mae Jemison, who says, "Sciences provide an understanding of a universal experience. Arts are a universal understanding of a personal experience. They are both part of us and a manifestation of the same thing. The arts and sciences are avatars of human creativity." So I think I will stop there with this message that there is no planet B.
Thank you for such a unique perspective on this. I, I would say that I was suggesting that there could be a solution in technology, but I'm not saying it's the be all end all thing. Regarding a point that you have brought up, and it's kind of connected with what I was saying earlier. You pointed out that we have really beautiful dark skies, something that's not really visible in any of our cities. Okay, that is something I also enjoy as an amateur astronomer. I like dark skies, but if you've heard of the Starlink project and how it's affecting the dark skies, how it has the potential to practically neutralize all of our big telescopes, um, at the same time being quite necessary for rural areas. So in terms of their internet access. So there are such complicated issues where technology is also clashing. It's also bringing up people from poverty, but it's at the same time, it's destroying something that could not be sustainable if it goes on. So how do you feel about this? I'm very conflicted on this, honestly.
No, I'm not conflicted at all. Because I think that it is a flawed concept to have things like what is a common good, what is a public good, which is space, be occupied by private interests. That is doomed from the start. So that is just not a tenable concept. Technology is essential, yes, but you have to see where are the outputs, where are the fruits of that reaching, who are they reaching, who are they depriving. because there are a lot of people who are going to be deprived. And honestly, the goal of the Starlink project is not to bring people in rural areas out of poverty. Honestly, it is simply profit. So it is going to be, a flawed, untenable idea in the perspective of sustainable future.
Okay, I get your perspective on that. That is something that a lot of experts have been pointing towards. And again, it's the way that I get conflicted on this issue because it's so complex in nature. I see that it could be taken that way.
I
Um,
mean, at the end of the day, the fact that that light pollution picture that I showed, that is just a symptom of where we are headed. That is not the problem. It's just one of the symptoms of how we are approaching uh, the use of our the use of the earth and its atmosphere and space around us. Yeah.
so again, drawing on this, taking it in a different direction, how do you think that some of our young participants, as they grow up, how should they look at the world if they are trying to approach sustainability while trying to balance the effects of technology or their own creature comforts?
Wow, that's a very, very big question. But I think, I mean, it depends. Different people have different imaginings. In my opinion, the only tenable imagining is sort of a society, an equitable society, where everybody, where methods and mechanisms and technology, which is only one of them, and political processes and all that, are geared towards equality for all. So it is only, in my opinion, that is the only tenable imagining. And then everything follows from there. So what do you need in order to do that? I mean, things will be local, things will be complicated, they will be specific, but I think that's the only tenable imagination.
Thank you so much for that, Professor Shastri. We have just been joined by another one of our guests, that is Professor Dipankar Banerjee. So just a moment. Let me try to get him in the screen, in the shot. Hello, Professor Banerjee.
Yeah, hi, Apurv. Yeah.
Can you hear me clearly?
Yes,
Is
I
my
can
audio?
hear you clearly. Yes.
So, welcome to the show. And I would like everyone to know who, I would just like to give a brief introduction for Professor Banerjee. Professor Banerjee is the director of the Aryabhat Research Institute of Observational Sciences, also known as ARIES. It's the same observatory that controls India's largest telescope. So that's kind of something that I also like. I'm Okay, so he's an astrophysicist with a bachelor's degree from St. Xavier's College and a master's degree in theoretical physics from the University of Kolkata. He has obtained his PhD from the Indian Institute of Astrophysics and has completed 2 postdoc tenures in reputed European institutions. He has been investigating the sun and the dynamics of its atmosphere for some time now, with a focus on solar magnetohydrodynamics and the sun's effects on space weather. He's also the co-chair of the Working Science Group of ISRO's Aditya L1 mission, and he's also the project coordinator for National Large-Scale Telescope Project. So all of that is pretty exciting. Hello, Professor Banerjee. And so just now we were in the middle of our discussion on the topic. We were discussing how we can integrate science and technology with a sustainable future, how we have to balance that. So we would love to hear your views on the issue as well. So I would now call you onto the virtual stage and give it over to you.
Thank you, Apurva. Yeah, nice to see you, Prajwal, after many years, actually, although virtually. We've been colleagues at Bangalore. I was not actually aware that you are also on this room. It's very nice.
Hi,
Yeah, very nice. Thank you. So I think Prajwal has already placed it in a right, level, that sustainability means a lot about our attitude towards doing science and technology and how we integrate things. So I think common sense has to be there first, that whatever you do, it is for the good for the society, and it is not harmful for somebody, whether it is a human being, whether it is space, whether it is other animals or plants. So I think that integrated approach is required, that as a long-term, what are the effects? Any technological, advancement always has a possibility of, other impacts. I mean, alternative energy sources, the nuclear energy is considered to be one of the, best possible source, but it has other impacts. So one needs to find a balance and, see what is best for the society. So, giving everybody the equal opportunities, treating everyone with the same, platform is required globally. So common sense is, I think, most important in this regard. And people, if they're aware of the, some of the, implications or adverse effects, you may not know in the beginning. But as you progress, you have to have an open mind to realize that, this is the way it is growing, it's not good for the society or the nature. So you have to make alternative arrangements for that. You have to be open for this. And see, science is always with this openness, which is very important.
I totally agree with that. Again, at times these things get very muddled when we are talking about our intentions, or when we think about sustainability as a concept. Everybody's on board because we want to live good lives, we want to support each other. But when there are conflicting interests, or when disruptive technologies, like let's say Bitcoin, something that has the potential to change the world, at the same time it is something that has a huge negative impact on the environment, and has the capability to disrupt societies as a whole. So how do we balance that? That's a big question here.
Yeah, so I think you are also drawing a sort of conclusion too early. So as you said, it is a disruptive, it's again a view of a few individuals or few way of looking at it. Maybe, it will grow with time and alternative, because digital mode is not bad. It's just because we are not used to it, right? So there are certain advantages of, I'm not an expert in the economics, so I can't really say too much about it.
But that is just an example of
I get your point. But what I'm trying to say is, just from your approach, I'm just saying that not to make conclusive, arguments or statements very early phase of its, introduction. Bitcoin is a very new thing. We don't know. I mean, of course, how we accept these changes, there has to be regulations. There has to be, because a lot of people can be misguided, and they may lose their, livelihood also by going into the wrong direction. So, of course, society and government and higher up should be careful about it and should have a proper guidance. But we don't know. I mean, if a proper analysis is done, proper system, studies are done, a comprehensive analysis has to be done. So don't need to really, jump into conclusions too early. I put it that way.
Okay, I think
let me give you another example, since you said, sustainability. Today we are so much dependent on space technology. We need, satellites. We need satellites for communications, for our defense, for our science. But how well the space is getting completely garbaged with a lot of debris. Space debris is a headache now. It's a huge headache. It appears that still there is no real consensus or very solid international, policies about, satellite launches, their lifetime, how different kinds of fuels are used, and then at the end of the day, when the satellites are, dumped into space as a space debris, how do you monitor that? So these awareness is coming now. But probably it should have come on, a decade back at least. So I'm just saying, so these are sustainability problem, because tomorrow you never know. I mean, 30 years down the line, if you're not aware of the space debris, the way it is growing and all that, it may be really, really, any day you will see that, this particular launch was, failed because of interaction in the space. So that's a real likelihood. So sustainability is also need to be studied, and for a long-term view also.
Yes. In a similar vein, regarding Kessler syndrome, the presence of space debris that we have discussed just now. If we think about the recent launches that we have got, all the private players that are entering into the space, and there are fears associated with the inequities that are being created just by their presence in this field. We are sort of experiencing, like, there is a fear in the field that it is going to go away from the grasp of common people and maybe become completely privatized or completely corporatized. So, in light of Kessler syndrome, in light of the climate crisis, in light of the need to go off into space, again, how do we bring this together? If we want to have a sustainable future, how do we guide our next generation to think about stuff? It's important to think the right way if we are trying to move towards sustainability.
Yeah, I mean, if you have to move towards sustainability, even from India, there's been a formal announcement that Indian space is going to be privatized.
Mhm.
So US has already done it. SpaceX is doing a fantastic job. So I don't think there is any problem in that. So again, we have to have open mind that industry is ready for taking up this kind of challenges and all that. People say there's nothing rocket science. I mean, there are rocket sciences, but rocket science also becomes a sort of, very organized sector. And that can be expanded to the, private players as well. ISRO may get involved with the next generation, I mean, if they're talking about manned mission and so on, so forth, the private players will not be able to do it in India. But standard, commercial launches and all that, I think it is straightforward for, private players to participate in and all that. So since you mentioned this, so I think again, in my opinion, we need to have openness, but still proper regulations are required. Proper regulations are required. Proper, guidance is required from the people who have already experienced these things. They should participate in some way or other in these exercises. Unless there is a lot of sharing of informations and all that. Incidentally, probably you are all heard that the SpaceX 40 satellites were lost a couple of weeks back.
Yes.
It's just a space weather effect. There were solar storms in the sun. It's just not the particles which actually hit the satellites. Because of the space weather effects, what happens is, there are changes in the densities and, heliospheric environmental conditions. So that will introduce different kind of drag as the satellite, goes into the space. And those drag calculation, whatever they had, was simulated in a normal solar conditions. They did not take into consideration of a, space weather effect kind of scenario. And that has led to these 40 satellites to be destroyed. So I think, so this kind of experience is required. So if SpaceX being, they have probably not interacted that much with the scientific communities. So since, today's theme, the National Science Day's theme is science and technology. And I think I also like what Prajwal mentioned earlier. See, technology cannot happen without science. See, any advanced world, that's why they invest so much on basic sciences. Because if you are not developing yourself for basic sciences, you have to always hire the technologies from somewhere else. And nobody will give you the most modern technology to implement it, free. So it is important that that handshake is very important. So it is important that the science and technology works, and have a good shake hand. And in fact, there are many projects within India now which demands such involvement. And a lot of students, I mean, since it's a students platform, sometimes they get chosen too early in their career to take, say, engineering or science. As they grow, with the higher degrees and so on and so forth, if we have provisions for these lateral, shifts or changes in the career path, that is, I think, the way forward. And such opportunities are coming within India. And there are many projects, I'm involved with this Aditya mission, where we work so closely with so many engineers, and I learned some basics of engineering from them. And likewise, they also get fascinated when we talk about why we are making this payload, what is it we are going to do after we reach the L1 point, and so on. So I think that is the excitement what we can share. And so unless we do this sharing of knowledge and information, we will not go too far. And the sustainability in that context, I think this is again another element, is our openness to learn new things, whether it is something of by definition a technology concept or a science concept. It doesn't exist actually. I mean, it's just our narrowness of the mind that
The lines are blurry.
Newton's laws of motion is only theory. It's Newton's laws of motion is applied anywhere in the nature. So, yeah. Okay.
In the meantime, while we were having our discussion, we have been receiving a number of questions from our students at the same time. So I think this one is for Professor Shastri. I think this would suit her more. Students are really curious about your work related to black holes, and they have questions related to white holes. So they are interested in knowing that whether white holes exist, whether they don't exist, is this just a theory? Are they a real thing?
Yeah, so black holes, that's a story for another day. It's a long story. I just gave some glimpses. White holes are speculative as of now, no evidence for them.
Okay. So, right. In again, connecting what we have been going through this whole time in this whole discussion, we have been discussing our attempts to go off into space, specifically the modern attempts by a privatized industry, and their aim is to maybe settle on another planet like Mars, or creating colonies on the moon. So, do you feel like there's a sense of abandonment related to the Earth itself, like we are going off, jumping onto a next planet, we are done with this, or that's just a limited thing with a certain group of people, and largely people want to support the Earth?
Is that for me?
Yes, that's for you.
Yeah, so abandon, I mean, first of all, I think it's projected in very confusing ways, very deliberately. As a scientist, I'm not excited by it because there is so much to learn about planets and all that with robotic instrumentation. Robotics has advanced tremendously, and so we don't need to send people out to do scientific work. So the science questions that intrigue us about planets and about our solar system and how it relates to other systems and whatever else, what is the geology and so on and so forth, all of that can be addressed without sending people there. So to me, so it doesn't excite me as a scientist. It disturbs me as a citizen because I think investment is being made in the wrong directions at a time when we are facing climate catastrophe, an equity catastrophe, a public health catastrophe. So it just is completely misguided. The third reason I don't like it is because it is presented in very these confusing terms. I mean, it's all about exploration, the cowboy syndrome kind of thing. Let's go to a new. And if that is all it is, then definitely there is a sense of abandonment, but it's misguided both ways. I mean, it is wrong to have this sense of abandonment, and it's not going to happen. I mean, all science research tells us that we cannot run away. This is the only option.
There is no planet B. That rings in my mind again. We have another question coming in from the students.
If I may just add one point, which is a sort of I hear from the space scientist. Of course, I don't deny what Prajwal is saying in philosophical terms. Apparently, if you really want to go farther out in space, then direct flight to farther out is much more troublesome. So what people are looking at, as you mentioned, not a colony or something, whatever, a base station in moon, because then, but as Bajwal mentioned, that for that you don't need humans. You actually can have with the robots as well. But then you have a station which is circling around the moon, and then you refuel, and you take a halt in moon, and then you go further. Because once we go out of gravity and so on, apparently it is much easier to travel further. So similarly, people are talking about going to Mars and making a base station in Mars, because the way the space station was conceptualized, it has not come out to be too useful for space exploration. It is useful for space, probing the space and monitoring Earth. But for space exploration, it has not been that useful. So having a space station in the moon or any other planet is for traveling to farther out distance. So, I mean, I'm not talking about the human part of it, or space tourism and all that. I mean, just from the scientific point of view, I'm saying that's probably they need to do that at some stage.
So it's a stepping stone of some sort.
Yeah, it's a sort of midway, halting place to go further.
Right. You mentioned interacting with engineers, and that really resonated with me. I'm also from an engineering background, and I ended up in the world of space. So for young engineers or people who believe that they are meant for engineering, they have an aptitude for engineering, what would you say to them if they are thinking of being associated with space, or how should they approach this? Again, in the light of sustainability as well, because that's the theme.
Yeah, I mean, actually, one needs to first find out, I mean, if it is for me, I mean, should I answer this?
Sure, it's open for everyone, I guess.
Okay, yeah. So with my experience, even if you come from an engineering background, you see there is a variety of things which there are different branches of engineering, right? So I think for any individual, whether you do science or engineering, I mean, you need to find out where your passion is, what really you like to do more. So these days, a lot of youngsters, they love, coding, they love to handle data. So big data, in terms of, astronomical observation and then output, I mean, this is a perfect, field for big data, right? So all the kinds of modern AI ML applications and all that are getting first, apart from the stock exchanges, can be tested in a lot of statistical way in astronomical applications. Just one element I'm just talking about. But if you are interested in building instruments, then because again, astronomy is a field which has actually demanded that I need to look at a very faint object in the sky. That made to the discovery of a CCD camera. And you all have a CMOS, which is a sort of a CCD camera in your mobile phone today, as a essential commodity, was not existing in early 90s. So astronomy, demanded this, technological demanded this kind of advancement, and a lot of engineers participated in that, right? So they were engineers. Then they looked at, I guess, night sky as well. And then some of them, I mean, if you go to NASA, actually, they don't make even that such distinctions, actually. So it's again, I always, the same statement I make, that if you're open-minded, you just find out what is your, where your passion is, and just try to follow that. Yeah.
Okay. I see that. I see how young engineers could keep that in mind, keep an open approach towards this, because it's very interdisciplinary, especially if we consider space sciences. It has it requires a lot of cross sections where we interact with a number of different people. Speaking of developing stuff based off of our technologies and scientific research, if we talk about satellites and how they are being used currently, they have a number of applications that could potentially save us, that could potentially help us track the changes that we have got on our planet. But at the same time, we are seeing them being used to as a tool in some kind of aggressive conflicts across different nations. It has been used as a tool for that for a very long time. Especially if you consider plans for a particular weapon that was considered a while back. If you've heard of rods from God, satellites carrying tungsten rods that could be used as bunker busters. So if you think about technologies like that that have such extreme destructive potential, how do we keep that in mind? How do we balance our ethics when we are building something like this? Because people say it's for peace, in quotes, but at the same time, it has the potential to do a lot of damage. So how do we keep it sustainable? Again, bringing it back to sustainability.
I think you will hear from Prajwal the best answer. Please go ahead, Prajwal.
I mean, there's no easy answer. I would say one thing that you should do is, in your list of things that you said you encouraged, you listed a few things, innovativeness and something. Mm-hmm. That were the core goals. I would say you have to introduce questioning. Mm-hmm. So it is absolutely essential that we build questioning citizenry, and if they have to be questioning, they have to understand the scientific method, regardless of whether they are scientists or dancers or cricket players or whatever. That is a huge deficit currently, and more so in India. I think that from a space technology perspective, actually, India was, now I can't say with as much confidence, but at least a year ago or a year or two ago, India was in a very good position to cast a different chart for space and use of space as a public good in the international era, which would involve getting together with like-minded nations and kind of eschewing the sort of, shall we say, militarism of the Chinese policy and the extreme corporatism of the US policy, both of which are very destructive for humanity, and build a different paradigm and build a different way of negotiating use of space. Weapons for peace makes no sense. You talk to any political theorist and they will give you a much better explanation than me. I don't have expertise in political science, but weapons for peace is just it just doesn't make any sense whatsoever. And so India did need to chart a different path. Unfortunately, we have not done it. We've announced a policy which just sort of, it's not too late, I guess, but so I would say we need a citizenry that questions and tries to shape a different people's policy for the use of space as a public good.
Definitely. Shooting first, asking questions later, that cannot be an approach that we take to technologies that have such an extreme potential associated with them. I have one interesting question for Professor Banerjee. And it also, again, it ties with something that Professor Shastri told us earlier about what kind of role art has in our life. So according to my understanding, Professor Banerjee, I think you're a part of a Bengali theater group and you regularly perform in theater festivals. So do you think there's a way for art to contribute to a sustainable future in tandem with technology?
Of course, it's just not art alone, say art, literature, sports, all kind of social, practices are required for a complete personality, So, and what happens is when you interact with personalities from different section of the society, then only openness come. And I think Prajwal was hinting on that, you have to listen to what other views are. So, so those things are important. So sustainability only can come when you take a decision while hearing others' view as well. If you just think what you are doing is the best and others are not to be counted, then obviously things are not sustainable. This will at some point of time lead to conflicts. So over centuries, over millennia, art has, of course, helped us to grow. So the societies have grown with several artistic impressions. I'm not talking about religion here, but every component have its own role to play. But you have to have a balance. Everywhere balance is required. Yeah.
Yes, that is an that is an insightful statement. I think I'll have to think over it a lot in order to process it, in order to adopt it into my own life. Right. So I'm sure our participants are enjoying a lot during this, and I personally enjoyed it a lot. It's been an enriching experience talking to the two of you, because it's something completely I get an insight into how you view the world and how I should in the future view the world. So I hope our audience is enjoying it as well. And it's been a lot of fun. It's been an experience that has helped me see a lot of possibilities and new realms for explorations for a brighter future. So we have reached the end of today's interaction. And I would like to end this interaction with a famous statement. The best way to predict the future is to create it. So I hope the participants today will use the learnings that we have got today to create real changes in the world. I'm very thankful to the two of you for joining us and sharing your wisdom with us. It's something that is going to change a lot of lives. Maybe if the people process all of that we have talked about today, it could be something that that would help them see the world in a different way. So I thank everyone here for joining us, and it's been a great experience. Thank you, everyone.
Thank you very much. Yeah. Bye-bye. Bye-bye. Good night.
Good night.